Hello, my name is Gabriel from GabakUSA. In this video we are going to talk about how a processor works. How does it work? So if you don't know that, I'm going to teach you first with these very simple examples, and then later on we are going to flip the whiteboard, and then we are going to go with the complex stuff. So we are going to start with the simple stuff in this side. I hope it will not reflect too much. Okay, I'm going to leave it like that. I think it will be good enough. So what is a processor? A processor is a central processing unit. So it will be like the brain on a human being. So we have here Mr. Wolf. So in this case, we have a brain that goes here, here. So, and we have a few other things that will be very important to know. We have a heart, I'm going to tell you why a little bit. Here we have the refrigerator, and I'm going to explain why. So in this case, we have processors. We have two different brands. The main ones are AMD, and then we have Intel, and then we have, in this case, we are going to use as example Pentium 4, 3.4 gigahertz, and then we have the internal clock. The internal clock is the speed that you see on the processor when you're going to buy a microprocessor. You will see, okay, 3.5 gigs or 3.4 or maybe 4 gigahertz or whatever. So that is the speed, so how fast it goes. The thing is, sometimes you cannot compare that because you may have two different processor, one from AMD, another from Intel, and maybe one will be faster than the other one, even though one is, even though they have the same speed. Let's say that you have Pentium 4, 3.4 gigahertz, and you have the AMD counterpart, and you say, well, why AMD is a little bit faster? I don't know, I'm just making it up. We have to make some tests in this case, but that is the thing. So that means internal clock usually is how fast the processor goes, and then we have the external clock, also sometimes called FSB, a frontal serial bus. Today they call it a quick path. In AMD they call it something else, but that is the basics. So, and then we have the multiplier. Usually when you start setting up the processor and everything else, you will see, okay, in this case we have 200 megahertz by 17, and then we have 3.4 gigahertz. That is the total amount that the processor will go. So if you try to overclock it and do something like that, usually it will last less. So it's like a human being. If you drug an athlete so they can run faster, something like that, you will decrease their span life. So usually their body will degrade faster. So that is what I'm trying to say. Try to keep using the processors at the speed that the manufacturer says, and everything will be okay. So now we are going to keep going. We have processors with different cores. What it means? It means more cores. Usually you can process more things at the same time. Usually in the human body we have one brain, and that's it. So usually Pentium 4 was one core. One core is one processor. You don't have many processors inside. You have sockets. So socket will be like the plug, the electric plug that you put in your socket in your outlet on your home or something like that. So there are many. So depending on the model of the brand, you cannot exchange one with another. If you have your motherboard is AMD, you cannot install the Intel processor, vice versa. So that is the main thing. And you have the cache. So the cache, usually you have L1, 2, and 3. So those are like special memory that resides inside of the microprocessor. So usually this kind of memory, it could be a half megabyte, 1 megabyte, 6 megabyte, 12, something like that, depending of the brand of the processor. Usually those kind of memory are much faster, so instead of going to fetch the the data into the RAM, if the processor has the data inside, it will be much faster that way. So that is one of the terminology that you're going to see many times. And here we have the set of instruction. It will be like the language or something like that, so the processor can understand everything that we are everything that we send to the processor, so that way it will understand. And regarding to the set of instruction, you will think, well, why is this important? Do I care? Not? Okay, I don't know if you remember the voltage. I forgot to say here. Okay, voltage usually, at least in this case, is 1.65 voltage. So that is why it's good. It's like a human being. It needs food, good electricity, and needs a pulse, because it will be the clock that I'm going to start talking in a little bit. And we have the brain, so everything will work. And the body, of course, is to keep everything together. So now we are going to keep talking about the set of instructions. So in this case, the set of instructions, for instance, we have a quick sync. In this case, today I have a Mac Pro late 2013. We are now in 2016. So for 3 years, Apple didn't upgrade their computers. So I have another computer, is a MacBook Pro. So it's a notebook, and I have a desktop computer, the small trash can, like most people say. Okay, so this is the thing. When I'm recording in 1080p, and I want to share the video, export the video, or however you want to call it, so I can upload it to YouTube, like you are seeing right now. And I did this test, the same video, same everything, on my desktop computer, on my Mac Pro, and it takes, let's say, for half an hour, maybe it takes 20 minutes. And then I do the same video, I use it in my MacBook Pro, in my notebook, and it takes maybe 5 minutes. So less than half of the time on the other computer. You're thinking, well, why that? I mean, my notebook is 2012, it's older computer, and I have my other computer that is newer and is much powerful. In this case, I have in this notebook, like as in the notebook, I have 16 gigs of RAM, and it's quad-core i7 2012. And in the desktop computer, in the Mac Pro, in the trash can, is 32 gigs of RAM, Xeon 6 cores, and 2 video cards. And you're thinking, wow, how is that possible? Is the notebook faster than the desktop computer? How is it possible? I mean, I pay, maybe for the notebook you pay $2,000, and for the other one like $4,000. And so you're thinking, well, why that? Okay, there's something very simple: quick sync. Because the i7, it has quick sync. That is the set of instructions that will help you to export the video much faster. And the other one doesn't have it, so it's much slower. So it's very slow. But the thing is, when you have to edit like 4K videos, and you have to apply a lot of effects and all the things, or maybe you have to do multicam and all the things, the desktop computer will be faster in that case. But the last step, when I share it, it will be a nightmare. With the other computer, it might be very fast because it has that set of instruction. But if you have to use multicam and all the things, or 4K, it will be kind of slow. So that is the set of instruction. In this case, quick sync. So that is one has Xeon, the other i7. In the future, I saw that with the Skylake, they're going to apply quick sync as well, but Mac, at least Apple, they don't have that right now. So now we're going to see the other side. So that way, let's see. Okay, great. Like I said before, CPU, Central Processing Unit. Okay, so you have the, like I said, in the other side of the whiteboard, you have the Mr. Wolf, and when you start sending the pulse, that will make the processor go a little bit faster. So let's talk about the pulse. Like I said before, the cycles. So 1 hertz, it will be 1 cycle by second, per second. We have 1 megahertz is equal 1 million of cycles per second, and we have 1 gigahertz equal 1 billion of cycles per second. So that is very important. That is the speed. That is how it is measured. So when you go buy a processor, you will know. So here we have the man. This man, we have to teach him how to fetch our data, how to start working with the data. So we have 4 tables here. The guy is going to work. So we have those tables are called registers. So we have general registers. So here we have AX, BX, CX, DX. So that way, when we give him data, he is going to store it on those places. Okay, we have the RAM here. This line that you see here, over there, is the processor. Over here is the rest of the computer. So that is what you're going to think. Okay, the only way that we have in order to talk with this guy is through the wires. It will be the data bus. So if we have to talk with him through this, it will be like small light bulbs, if you want to, if you're willing. So when the light bulb is on, it means it has current. And if it is off, it means it doesn't have any current. That is why it's off. So in order to communicate with the guy inside, we are going to use binary numbers. So we use decimal numbers. That is why we have 10. But the guy inside will understand just zeros and ones. So electricity 1, no electricity 0. All right. So we have, the guy knows, okay, now we are going to start keeping, we are going to keep communication through this wire. So when you send me a current, I will see a light bulb on, so that means it's 1. Remember, there is no light bulb inside of the processor, just is an example. Okay, then the guy say, okay, I have the tables here to work. We have the communication, the wires, and the guy will say, okay, how can understand each other? I mean, how can understand you? How can this guy understand the RAM? I mean, the information that we have in this side. All right, and then for that, we have the code book. We have the code book or set of instructions. So with that, the guy will know everything that we have to say. So in this case, we have a very few examples, or very few set of instructions. Indeed, there are a lot more. This is just an example, something that I made up. So when I send in this data bus 1 0 0 0 0 0 0 0, so it means the first wire will be on and the rest will be off, and then that means something. And then, okay, how does he know about that? Like I said before, with the set of instructions. So the first one will be, the next line is a number. Put it in the AX register, so in this table. And the same thing with the other one. So the next, the 1 0 0 1 0 0 0 0. The next lane is a number. Put it in the BX register. We have the other one, 1 0 1 1 1 0 0 0. Add AX to BX and put the result in AX. So we're going to put the result here. And then we have 1 0 1 0 0 0 0. Put the value AX on the external data bus. So that means it will put the information in this side. So we have the numbers, and then the numbers, remember, we have 0 in binary is 0. We have 1 is 1, and 2 is 1, and then 0, and then 3 is 1 1. It's not 11, it's 1 1. All right, and then we have until 5. So that way that is how it's going to work. So, and then we have another thing, is the clock. the clock will let him know when we finish sending the instruction. So we are going to send the instruction. So the guy will start asking, okay, send me information. And then remember the RAM, just in case, is like something else in your home or in your office. Everything has a place, or maybe your home, your office, or maybe your neighbors, something like that. Everyone has an address. So the memory RAM has an address as well. So the guy will start saying, okay, I'm going to pull information from the X address, any address. We're going to talk about memory in another class. So, and then what it's going to do is we have two data bus address, and then we have the data bus, and then we have the address bus. So it's going to send the information in the address bus here to the RAM, and then it's going to ask for certain address, the information. And then the information will go from the data bus to the processor. And then when it goes like that, in order to go where it has to go, the processor will set the enable wire. So it has one wire that is enabled. So enable it, send the address, send the information, and then it goes to the processor. Okay, now the guy is ready to work. So remember, we have the clock cycle. So every time the clock, in this case, the bell rings, it means I'm going to pull the data, I'm going to work. And when I finish, I'm going to get another clock alarm. So that way, each time the guy gets the clock, start working or do the next step. So this is how it works. So we have the RAM. So we have the data bus. So we are going to receive information. So what the guy is going to say, okay, I'm going to request the data from X place on the RAM. Remember, everything on the computer, it has an address. So that way they know how to fetch the information. Like your home has an address, and your neighbor has another address, and that is how everything works. So the guy is going to ask for information in X address on the memory. So in order to do that, once it pulls the information, send the information, okay, I need this, and then the processor will enable the enable cable, so that wire, and once the RAM has that signal, it's going to send the information through the data bus, and then the guy has the first instruction. And then like that all the time. So address where I'm going to get the information from, and then I get the permission. So they enable this wire, and then the data from the from the RAM will go to the processor through the data bus. And then like that all the time. And if they have to do something in burst, so the processor has to send information, they have to record information and instruction in the memory, what they're going to do is they're going to send where have to be recorded, and then it's going to send a signal through the set wire, and then it's going to send the information through this side of the data bus, and then it will be overwrite whatever is in that place, or there was something before, it's going to be overwritten. So that is how it works. So we have the one instruction key, we have a small program. So the first one will be 10000, and then it means put a line AX. So it means, okay, the next line, so I try to abbreviate it, so it will be that. And so the next number will be 00010. Remember, it is number 2, so that is the number. So it will add this number on the AX table. And then the next will be put in line BX. So put the next line in the register BX. So this is the register BX. So the next instruction will be number 3, 11, and then we have 2, and then we have 3. Okay. Next, what is next? Next is AX plus BX, and the result will go here. So it will add both numbers, and then the result will be recorded in the first table. And then the last instruction will be 110000. Put a value in the data bus. So it's going to send this somewhere in the memory. Like I said before, remember, everything has a place. So we have to know the processor in this small program. Remember, this is kind of example, so you know how it works. So we will send one place to send the information where it's going to be recorded, and then this cable will be enabled. We'll have the current running through this wire, and then the information will be recorded in the RAM. So that is how it works. Okay, another thing that is very important here, we have data instructions. Like I said before, everything has an address. It could be a printer, it could be just to see on the screen or something like that. And then we have another things that are very important, another instructions that it will be like load, add, store, compare. Usually load is from RAM to CPU if you want to, or add, it will be add two numbers together. You have a store, okay, store from the CPU to the RAM, and then you have compare, it will compare one thing with another thing. And then you have if condition, so that means, okay, if this number is bigger than this, and then do something else. If you know how to program or how to code, that will you will remember those things that I'm saying right now. And then you have another thing, another set of instruction will be like jump. Okay, jump no matter what. You say, okay, you're doing this, and then jump to this place. Yeah, I mean, it doesn't matter if there is no condition in that case. You have an output. Output, like I said before, it could be a monitor, it could be a printer, it could be something else. And then you have the in. It could be the keyboard, mouse, or something else. So I hope everything was clear. If you have any question, remember you can write me a comment in the section below. And regarding about the refrigerator that I say with the food and everything, is because if you want to have a nice computer, remember to have a very good power supply. If the current is great, if the motherboard has a good capacitors and all the things, everything should work just fine. If you put everything that is very cheap, computer usually are not going to be very stable. I have another video about that, how to replace capacitors and other things, but that is out of this of the scope of this video. You can go to the playlist if you want to see more. So I hope everything was helpful for you. Remember, subscribe, and see you next class.